sports. There are 8 open slots in badminton, 13 in football, 17 in baseball, and 12 in volleyball. Notice that makes a total of 50 slots. How many ways can the students be assigned? So we're going to look at this in 2 different ways. The first way we're going to look at it is through the idea of choice. We're going to make different choices to begin with. So we start off, and let's work on badminton first. We have 8 open slots for badminton. So what we're looking at is how many ways are there to choose 8 players for the badminton group. So 50 students. So if we've got 50 students we're choosing from, how can we choose 50 choose 8 is all the ways we can choose our badminton group. Next up, let's work on the football group. So football group, but it's not going to be 50 choose 13 because how many people do we have at this point? Well, we just did badminton, right? We are now reduced by the 8 students we put into the badminton team. So we don't have them to work with anymore. So it's 50 minus 8 students is how many people are left. So 50 minus 8 is 42. So there are now 42 students left for looking for how we're going to put football positions around. So 42 choose 13 is how many we can have for football at this point. That's all the choices for football after we've already done the choices for badminton. Next, let's look at how many we can put into baseball. So once again, we have to reduce the student pool that's left by how many people we've already put in for other things. We already had 13 go into football from 42. So 42 minus 13 becomes 29. And now we are choosing 17 for baseball. And finally, 12 for volleyball. 29 minus 17 means we have 12 students left, and of course every single one of them is automatically going to be chosen for volleyball. 12 students, choosing 12 students out of them, well, every one of them is going to have to go into volleyball because they're the group left over. If we work this out, with what these mean mathematically, 50 choose 8 is 50 factorial over 8 factorial times 50 minus 8, so 42 factorial. Next up, times 42 factorial divided by 13 factorial times 42 minus 13 factorial, so that comes out to be 29 factorial. Next one is times 29 factorial, what we're choosing out of, divided by 17 factorial, how many we're choosing out, 29 minus 17, 12 factorial, times 12 factorial, divided by 12 factorial, times 0 factorial. 12 minus 12 gets us 0. So that's an important reason. Right there we see why we defined 0 factorial. Remember, 0 factorial equals 1. We just defined that, and that's so we don't have things like dividing by 0 happen over here, so that 0 factorial just cancels out nicely. Now notice at this point, we've got 42 factorial on the bottom here and 42 factorial up here, so they cancel each other. Same thing, 29 factorial, 29 factorial, they cancel. 12 factorial, 12 factorial, they cancel. So that leaves us, in the end, 50 factorial on the top, divided by 8 factorial, times 13 factorial, times the 17 factorial, times the 12 factorial. So that is the total number of ways that we can put this out for all of our team assignments. Now notice that is an exact perfect answer. That is correct, but it's not a number. So we might want to use a calculator to get an approximate number. So we'd go into our calculator, find the factorial button, that exclamation mark somewhere in our menus. We'll be able to figure it out, put it down that way, and we'll be able to get the answer. So that's what it comes out to be. We'll have to work through a calculator to get an approximate answer, but that's the precise answer. So this is the answer right here. Now, alternatively, we could have done this in a totally different way. We could have also done this through arrangement. Now, the arrangement way is a little bit more complicated to think through, I think. But it works faster, and I think it's a little more satisfying. But the choice method works great. If it makes sense and this arrangement one doesn't quite make sense, use the choice method. Whatever makes most sense to you is the way you want to work. But the arrangement method, you might find that this makes sense, and it will go even faster. So the way we have to think about this first is we can think about this as putting all 50 students in a line. So we line them up alphabetically, whatever. We line up the 50 students, and then we keep them there. We don't let them move. They just stay in their position. So we have lined up students there. Next, we think of badminton, football, baseball, volleyball as cards. So there is a badminton card, and we have a total of 8 badminton cards. And then there are, let's make that a BD because it's kind of hard to tell the difference between badminton and baseball if they both have that. So BD, BD are badminton cards. And then we've got our football cards. How many football cards do we have? Well, we've got 13 football cards. How many baseball cards do we have? Well, we've got 17 baseball cards. And then we've got how many volleyball cards we've got? We've got 12 volleyball cards. So we can think of this as these cards. And now the question is, how can we hand these cards out to the students? So if we think of our students as just standing there, little boxes, waiting to receive their cards. There's a total of 50 things, and then the question is, how can we place these cards in? Well, it's a question of how can we arrange these cards and hand them over to those boxes, right? We arrange the cards in some line, and then we hand it over to the line of students waiting there. So how many ways are there to arrange this set of cards? Well, we've got a total of 50 cards, right? This comes out to 50 total. So we have 50 factorial divided by, what are we going to divide by? Well, how many ways can we arrange the badminton cards? It doesn't matter if you get the first badminton card or the second badminton card or the last badminton card. They all mean the same thing. Go on to the badminton team. So it doesn't matter which way we arrange our badmintons, so we divide by 8 factorial because the arrangement of our badminton cards doesn't matter. Next up, we divide by 13 factorial, all the ways that we can arrange our football cards. Then we divide by 17 factorial, all the ways we can arrange our baseball cards. And then finally, we divide by 12 factorial, all the ways we can arrange our volleyball cards. So what we're seeing here is we're seeing distinguishable permutations of our cards. All of the ways that we can have distinguishable permutations of these 50 assignment cards. So we can look at it as choosing students for the teams, but we can also look at it as arranging cards that we then hand over to the line of students who just waits there. So this also winds up getting us the answer, and notice they are the exact same thing. So both ways are equivalent. They get us to the same thing, which is good. That's what we'd hope for. If we work this out with a calculator, we wind up getting that it comes out to approximately the ridiculously large 7.1 times 10 to the 26th ways that we can arrange putting our students in these teams. That is a ridiculously large number considering we're just putting 50 students into 4 teams. It's amazing how fast these things get when we're working in combinatorics, when we're working with permutations and combinations. Pretty cool. All right, so that does it for this lesson. Next lesson, we'll see how we can apply this stuff to probability and how we can use all of our work here to get an idea of how likely is a given event to happen. All right, we'll see you at Educator.com later. Bye.